we'll talk about vector and commercial calculus. Vector and energy calculus. No need to say energy calculus. Wherever vector is there, certainly there is energy. Wherever there is vector, there is energy. Energy, what is energy? Energy is nothing, I'm sorry, what is a vector? Vector is nothing but energy flow in a direction. So when there is energy flow, then there is a vector. Hope. Vector means energy which has a mass and a direction. I give example like a person is running, then he is running at what speed? A person is running at 10 kilometer per hour. Very nice. In what direction? One is direction and one is magnitude. One is direction and one is magnitude. So all one is direction and one is magnitude. All together, this is called vector. Energy. Energy has magnitude and energy has direction. So altogether, it is a vector energy, whatever someone would say. Okay, there are two kind of vectors. One is called static vector. Static vector is represented through orthogonal component. I have a vector means 2I plus j, whose x component is 2 and y component is j. They are orthogonal to each other. Okay, this is called static vector. 2I plus j, if this is x-axis, this is y-axis, 2I plus j means along a particular direction, a straight line. What direction it is? From this is origin, this is 2 comma 1. Make a line, this is the direction in which the energy is moving. What is the strength of the energy? 2I plus j, 2 square plus 1 square square root. Square root of 5 is the power of energy. And it is moving in what direction? It is moving in direction from origin and 2 comma 1. If you draw a line in that direction, no. You tell me the direction. Okay, I'm telling you the direction. Direction is described by unit vector, which has magnitude of 1, that is the direction. Then it is 2I plus j divided by square root of 5, that is the direction. Okay, now we have gone too much in the kind of energy. So there is an energy source. There is an energy source, and energy source has force field. This is what we learned. There is a force. This is the problem in the mathematics book or any kind of paper, mathematical paper. No, there is a vector field F. What is vector field? I don't know. There is a, I'm sorry. There are two kind of vector. One vector is a static vector that we saw 2I plus j. There are two kind of numbers. One is called numerical and one is called algebraic. Both are numbers. What is the volume? What is the volume? Volume is 10 meter cube. Very nice. What is the volume? Volume is x meter cube. What is x that you have to think? Volume is x meter cube. Means my volume is x meter cube means volume is dependent upon some other factor x. This is calculus way. Calculus way means dependent and independent. If I consider x as independent variable, our volume is dependent upon x. This is calculus. Okay, so volume may be y direction and independent axis x is in x direction. There are two things. One is independent component, that is x axis, and one is dependent component, that is y axis. Okay, x axis, y axis. Y axis talks about the volume. Y axis talks about the volume. X axis talks about the independent component. Independent component is x, then volume is dependent component, that is also x, but it can be x square, x to the power 3, whatever it is. So this is dependent and independent component. Numeric and algebra. Numeric and algebra. Numeric means it has constant value. Algebra means a variable whose value can change. Similarly, there is a numeric vector which is a static vector 2I plus j. There is a variable vector, algebraic vector, minus 2yi minus 2yi plus 2xj, minus 2yi plus 2xj. That is a vector. Now keep changing x and y, your vector will start rotating the way you are changing it. Okay. So that is the vector. If I say my x is 1 and y is 2, then vector is minus 2i plus plus 1j. So minus 2yi plus 2xj is a variable vector. Vector would, that direction would keep changing. Direction and magnitude both is dependent upon x and y. Okay, the way algebra keep changing depend upon the x and y, the vector can also keep changing as per the x and y. What will keep changing? Its direction will keep. Okay, so direction will keep changing. Its magnitude will also keep changing. Both. So if it is algebraic vector, then its magnitude and direction will keep changing. That is the algebraic vector. Vector can also be algebraic vector. Now, from the algebra side, if we change x and y, then vector will keep changing. But from calculus side, calculus means dependent and independent. What is independent and what is dependent? So what is independent here? What is dependent here? Anyway, we will see that. And calculus works on algebra. Calculus never works on vector. So vector, if you want calculus, then component wise, you have to do calculus. You cannot all of a sudden full vector you can involve in calculus, not possible. Calculus is game of algebra. Calculus is not game of vector. Vector can be numeric vector algebraic vector. Okay. See the way a number can be numeric or algebra. Similarly, a vector can be numeric and algebra. What is the base of the vector? It will tell you the net magnitude and direction. That is the vector. Anyway, if I have energy source means it has capacity to attract something or distract something. That is energy source. Okay, I won't say earth, sun is energy source. Right now, I won't say sun is energy source because sun is a gas celestial body. It is hydrogen that is converting into helium, and it is a kind of energy source in the sense it produces light or heat, whatever. If I talk more in this, then black hole. Black hole is a kind of entity which does not have any light at all. Black hole. It is black means there is nothing out there. It should be null hole or vacuum hole or nothing hole. A region in the space, region in Khali. In Arabic it is called Khali. So in region in Khali area, a space area where there is nothing. If you take binocular or telescope, then you can see sun bigger. Okay. Then you can say there is something which is very powerful and very white, yellow, whatever it is. But if you take binocular or if you take a kind of high class telescope, still you cannot see the black hole because there is nothing out there, or someone can see very tiny thing or whatever it is. Full is energy. Full is energy. If light also passes through, it attracts the light. Light will go and it will go inside the black hole. Whatever is the thing that passes through the black hole, it will fetch it. Okay. So that is the system of black hole. Why that much is required? That much is required because black hole has to sustain full galaxy. So on the power of black hole, 98% of the solar system mass, Earth plus Jupiter plus this plus that plus 98% of the solar system mass is sun only. Sun is 98% of sun volume and other volume. If you the sea, sun is 98%. In 2% only others are there. Okay, if you see kind of Jupiter, in Jupiter is 1000 times lesser to Sun, 1000 times. If it is 100 times lesser, then it will be 1% of the Sun. If it is 1000 times lesser to the Sun, then it is 0.1% of the Sun. If you calculate all Earth and everything, I believe it will be 99.8%. I said 98%. I think better if I say 99.8% or whatever it is. That much big the sun is. That's why it is able to sustain full solar system. Okay, if I go with the galaxy, Milky Galaxy is a galaxy of Earth, Sun, Akash Ganga in Indian mythology. So Milky Way galaxy, the center is the Milky Way. Center is the uh, kind of uh, uh, black hole. If black hole is 99.8% of the full Milky Way, then it will be like it will be something that is not good. It only will be very big. Then you cannot see you cannot enjoy the kind of beauty of Milky Way. When center is that big, it will look awkward. Solar system would look awkward from outside. This is I'm certain about it. Solar system would look awkward because sun is very big. Okay, and other are very tiny in front of sun, like a very tiny, like a sand particle. It is that big one. Sun is a football. Then Earth is like a what you can say. It's a sand particle. It is very small. Okay, so God has designed in a way that the kind of what I was saying. Okay, black hole. So black hole is only energy. There is no mass or something like that. If light also passes, that much energy is required to sustain the Milky Way. Okay, so if I have an energy source, so generally book people find there is a force field. Sorry, there is a vector field. Vector field means algebraic vector. If there is a vector field, then this integration, that integration, people they start jumping in mathematics only. There should be reality in the mathematics. What you will understand with the mathematics. So consider instead of vector field, consider there is a force field. If there is a force field, then there is a energy source. Then why there is a force field? Now consider there is a force field because of there is an energy source. Now we have learned that energy source can be path dependent, energy source can be path independent. People consider Earth as very big mass, but I consider Earth as energy source because it attracts something. If you see black hole, then generally people will say, or any scientist will say, black hole is energy source because it is not a mass. There is nothing there in black. You cannot see black hole because there is nothing out here. It is not black. Name is black. Hole. There is a hole, like a well. Well is a black hole where if something goes, then it will go inside only. So it is a black well, but there is nothing out there. Sun is there. Other stars are there, but black hole there. If you see the center of the Milky Way, there is nothing out here. So, black hole is a kind of a star which is nothing. It is only pure energy source. So, if I consider force field, in example of mathematics, there will be a vector field. Consider it is a force field. If there is a force field like this, then certainly there is a black hole kept there. Like Earth is an energy source, that's why it is making anything move. There is a Newton's theory that Earth attracts something. Earth is a mass which has a gravitational pull and it attracts something. Wrong. I won't say wrong, wrong, because he is very, very high to me. I'm nothing in front of him. But anyway, okay, let's take another way. Mr. Einstein, Sir Einstein. So, as per the Sir Einstein, there is nothing called gravitational pull or here and there. Everything is energy only. So, Earth is energy source. If I leave this and it comes here, it's not because Earth pulls it. It's because since Earth has energy, it makes this item move from here to here. Okay, can you show me? Yes, I can show you. See, I have energy and I am making this item move from here to here. It is happening through your hand. No, it is not happening through my hand. It is happening through the inside energy in my body. Because of that energy, this item is moving like this. Okay, similarly, Earth has energy. Because of the Earth energy, item is moving like this. Earth is moving an item from one location to another location because Earth has energy. Okay, but that is connectionless. You are connecting. I am connecting, then only I am able to move it. Okay, no, no, it should be connectionless because you are not like a earth. Certainly, I am not. Why I am connecting? Why I am connecting something from my hand to move it where earth is not connecting? See, earth is there no connection from earth. Still, it is making it to move because earth is highly energetic. It's not a gravitational pull or mass into acceleration. Earth is highly energetic. Earth is highly energetic. I am not that much energetic. I'm sorry, I'm nothing, I'm zero in front of Earth. That's why Earth does not need anything to touch it and pull it, not required. Okay, so it can pull through connectionless, wireless, mobile, mobile kind of thing. Okay, but whatever it is, Earth cannot pull light. Earth can pull entity, which is which is to some kind of which is less energetic. Light is more energetic. Earth cannot make light move from here to here. Not possible. That is away from the Earth. But the black hole can make, if black hole is attracting light, you can read in the book, black hole can attract light also. This proves that black hole can move light. If sun is throwing light and it is coming to earth the way it is coming from the sun, then there is no problem. This proves that earth cannot move light. Earth is powerful, but it is not that much powerful that it can move light. But black hole is that much powerful that it can move light. This is another concept of energy source. Okay, one concept of energy source is if a thing is less energetic, then he has to touch it to move some item. If it is more energetic, no need to touch also. It can move item without touching it also. But to a level, to a level. Okay, I cannot. But if it is very light, if it is a feather, if it is a feather, then I can make it move. No need to touch also. Through air, I can move. If it is a feather. But if it is heavier, then I have to push it. Similarly, if there is something that is like this, then if someone would say light is light, it is not heavy, then earth should move the light. Light has, there are two ways people calculate the energy. One is mass. One is mass, through also people calculate how much energetic it is. Feather is less energetic because mass is less. But there is, and that's what Einstein is saying. Don't see mass when you are seeing the energy. See velocity. That is the main part of the energy. A mass, a mass with a velocity v, a mass with velocity 1 has energy m only. A mass with mass m has velocity 1 has energy 1 m only. A mass with velocity 10 has energy m into 100. Velocity gives more velocity, it makes more share into the energy rather than mass. Okay, so if feather is less mass, this is higher mass, certainly it carries more energy than feather. So I need to push it from my hand because it has more energy. But earth can make it move from one location to another location because earth is much more energetic than me. But if anything comes even heavier, even heavier, even heavier, I'm sorry. If anything comes that is even more energetic, more energetic, more energetic, more, there is a limit. Beyond that, earth cannot move also. So that's why I say whenever someone tackles mathematics or anything, go in energy calculation. Energy is the main thing, not the mass or velocity or whatever it is. This is what Sir Einstein is saying. Whenever you focus in any problem, anything, either you are a lawyer or you are a doctor or you are an agriculturist or you are anyone, okay, focus on energy. Don't focus on mass and velocity and color and this and that. You will fall. Focus on energy. So earth is making any item move from one location to another location only when it is less energetic. I can move any item, move one location to another location without touching it also. If it has less energy, if it grows in energy, then I have to push it. Similarly, light is more energetic than this. It looks lightweight, but it has velocity very high. Mass can be very less. This is what Mr. Einstein is saying. He gives the fundamental of photon. Photon. So the light is not like something. Light also has weight. Light is not weightless. It has a weight, very lightweight. But the velocity what it is carrying, 3 into 10 to the power 8. Oh, I don't know, 3 lakhs kilometer. 3 lakhs means 300,000 kilometer per second. That is the speed. How much energy it is carrying, whatever the mass is, into velocity square. Okay, 3 into 10 to the power 8 it is, that 9 into 10 to the power, how much it is? 8 square, I believe it will be 16. 9 into 10 to the power 16. Okay, that much. I don't remember if it is 10 to the power, if it is 2 to the power 2 to the power 3, how much it will be? Okay, 2 to the power 2 is 4. 4 into 4 into 4, 64. Is it same as 2 to the power 6? Or if I say 2 to the power 3, then it will become 8. If I go with power 2 to the power 8, 2 to the power 8 will go beyond. 2 to the power 2 is 4. Then power is, then again power is 16. 2 to the power 3 is 6. 2 to the power 2 is 4. 2 to the power 3 is 8. 2 to the power 4 is 16. 2 to the power 5, 30, 2 to the power 6 is 64. Means power will get multiplied, not it will go as power. So I believe 9 into 10 to the power 16. That is the and into the mass. That much energy it is carrying. It is very, very high. That much energy. It's a funny, right? Earth is pulling anything, then we talk about mass into acceleration, and mass into acceleration, mv square or whatever it is. Mass into gravity into distance or something like that. We go with the Newton's calculation. Okay, so Earth is making any item move without connection, with connectionless, because that item has less energy. But if energy crosses a limit, then Earth also cannot move it. The way Earth cannot move light, Earth cannot move electromagnetic radiation. That's why we are able to watch television and those things, because it is moving the way scientists or engineers they want. Okay, if Earth started moving electromagnetic radiation also, that the electromagnetic radiation coming from the satellite, it will deviate here and there. So Earth is not doing like that. Earth, it is beyond Earth's capability. That much energy movement is beyond Earth's capability. But if someone, if consider that between satellite, geostationary satellite, 40,000 kilometers, 35,000 kilometers, 30,000 kilometers from the Earth, if there was a black hole nearby, then all electromagnetic radiation that is coming from those satellite, geostationary satellite, they would have moved toward the black hole. Black hole is not attracting electromagnetic radiation. Black hole is moving electromagnetic radiation. This is true word. So if I have a force field, then consider there is a black hole, there is an energy source. An energy source, because of energy source, there is a force field. Anything that comes in energy source for which it can move it, energy source cannot move everything. Now we understand. Depends upon power of energy source. But if it is able to move something, then the work done or energy consumption that happens from energy source is depend upon the begin point and the end point. Then it is called path independent. If it depends upon the begin point, end point, and the path it is taking, it is called path independent. Okay, so we have seen two areas in path independent. How energy source is path independent? That is a query. How I can say the energy is path independent? Take a in any force field, if there is energy source kept in any force field, take one item that moves from one position and coming back to the same position. How much energy is consumed? If it is path independent, then energy consumption will be zero. If it is not zero, then it is path dependent. Compute the energy computation divided by the area the closed loop is forming. Then it is path independent. I mean that much it is path dependent. The what is the degree of path dependency of any energy source? Take an item and let it move in the force field of energy source in a closed loop. Calculate the energy consumption from the energy source divided by the area. That is one way. Second way is if you have a force field, any force field has component. This is F1 component of force field. This is F2 component of the force field. Df2 by df2 by dx, how much this f2 is changing along x, df1 by dy, how much f1 is changing along x. Because if this is f1 and this is the item, if it is changing, it will make a torque. And if this is f2, if it's changing, if I go in x direction, it will make a torque. What is the net torque this force field is making? Df2 by dx minus df1 by dy. If that is 0, then it is path independent. If that is not 0, then it is path dependent. How much it is path dependent? What is the nature of path dependency? We can simply calculate by the curl factor. This is also called curl factor, torque factor. And it is in two dimensions. Whatever we calculated, it is in two dimensions. It is in three dimensions. Then we have to go by a matrix calculation. I, J, K is the first row. D by dx, D by dy, D by dz is second row, and third row is F1, F2, F3. Calculate the determinant, and that ijk, that is the net curling factor in three dimensional. When the force field has F1, F2, F3, force field has F1, F2, F3 as its components. Now we are into Stokes theorem. So what is the tendency of path dependency of energy source? Take energy in a closed loop divided by the area, that is called circulation density, or calculate the curling factor, that is df2 by dx minus df1 by dy, k in k direction, if the force has x and y component only. Otherwise, you have to go with the determinant calculation. Otherwise, you have to go with the determinant calculation. Okay, so that is the scenario of calculating the kind of uh, curling factor, or the curling factor or circulation density, that tells the quality of force dependency in the energy source. Now Stokes comes into the picture, and he is now focusing more. Stokes is focusing more. Stokes is saying, I understand you can calculate circulation density. Very nice. I can understand circulation density is nothing but the curl factor. Curl factor means if there is an energy source, then how much torque it is generating. If it is making item move from this location to this location, then it must rotate. If it is rotating and going from either one position to another position, then this is path dependent. That is torque factor. If you know the curl factor, this is what Mr. Stokes is saying. If you know the curl factor, okay, if you know the circulation density, and if you integrate it, if you do the dot product of circulation density or curl factor has direction. Okay, what is the direction? Okay, consider that something is making torque like this. This is x-axis, this is y-axis. There is an energy source kept, and it is making torque in xy plane. If it is making torque, okay, so Mr. Stokes is saying that if something is rotating while going toward the energy source like this, and it is rotating in xy plane, this is x-axis, this is y-axis, consider this is xy plane, then whatever is perpendicular to it, this is the direction of the curling. Curl is rotating like this. Direction is what? Direction is xy plane. No, it is rotating in xy plane. Direction is exactly perpendicular to the rotation of the plane. That is the, it is rotating in this direction. Okay, it is x-axis, this is y-axis, this is z-axis. It is neither rotating in xz plane, nor in yz plane, nor in xy plane. It is rotating like this. Now tell me, what is the torque direction? And torque direction exactly perpendicular to the plane in which it is rotating. Okay, if it is xy plane, then the torque direction is along z-axis. Now he is saying, Stokes is saying that if you know the torque, or you know the circulation density, okay, if you know the circulation density, or you know the torque factor, integrate, do the dot product integrate it along the surface vector. Hope. If someone knows the curl factor, if you know someone knows the curl factor and he integrates it along some surface, then it will be same as someone is trying to calculate the energy calculation in a closed loop. Tedious, right? Okay. Now consider. Okay, now consider this is a closed loop. This is a closed loop in which item is moving in this force field. This is a force field. In this force field, item is moving from here and coming back to here. What is energy calculation? Then you can calculate the energy force vector dot dot displacement vector or dot d of position vector. Then it will be energy that is consumed from the energy source making item move from this point back to this point if this is path dependent. Okay, this if you divide it by the surface area, this is called circulation density. Okay, if it is circulation density, if you know circulation density, another way to calculate circulation density is circulation density is calculating the curl factor df2 by dx minus df1 by dy along along k direction. If it is x and y, or if you take 3D curl factor, then whatever will come unit vector that will be along that direction. If you know curl also, that is also circulation density only. If you know curl of any force field curl is not the is nothing to do with the path or something like that. It is purely the curl field of a force field purely talks about the nature of energy source. It has nothing to do with the path at all. But if you know the curl factor, or if you know the circulation density, and consider that circulation density is applied on a surface, consider this is a surface. This is a surface. This is a flat surface. Consider this is a surface. Okay, if circulation density is applied on a surface, any surface, this is a convex surface. If this is a convex surface, if I apply circulation density of curling factor on a curling factor itself can be an algebraic vector possible, where everywhere the direction will be different. Now, if I take the curl factor, now consider this is a surface. This surface is a convex surface. This is a flat surface. This is a convex surface. This surface every moment, this surface vector, what is surface vector? At every moment, what is the perpendicular that surface? If I take a delta x and delta y, consider this is in some point. If I take delta x or delta y, some surface area here. At that surface area, what is perpendicular here? This proves that at surface, every moment surface area vector is changing. Every moment surface area vector is changing. Okay, he is saying that if you integrate the curling factor, whatever curl, dot d of surface vector, mind blowing. The person who has separate brain, the curl factor, whatever you get, if you have a force factor, dot product with the d of the position vector, it gives the net energy calculation along the curve, position vector of the curve. If I have position vector of the curve, if you do force dot d of position vector, it will give the energy calculation along the curve. But Stokes is saying if you have curl vector, that is, if you have force vector, then df2 by dx minus df1 by dy k. This is the another vector that is called curl vector. If you have curl vector and if you integrate curl vector dot d of area vector, if you have area vector may not be flat. This is what I am saying. This whatever we are saying, the circulation circle, this area vector can be convex. Consider there, take a cloth here. Now take a rubber, take a flat rubber and bind and pull the rubber. Take a rubber or take a cloth, rubber cloth. There nowadays cloth come that is rubber. You can stretch it, stretchable cloth. Now fill the cloth and then pull it. So full part of the cloth will be tied. Sew it. Take a rubber cloth and sew it completely. And that cloth now pull it. Okay, that is also a surface. Then Mr. Stokes is saying that if someone knows the curling factor, someone df2 by dx minus df1 by dy, it will be algebra. Algebra means every point here, whatever we see, curl factor will be different. If I have a surface like this, every moment surface area vector is different. He is saying the curl vector dot d of surface area vector, if you calculate, then it will give you the energy around the line of the surface. The surface is alright, but at the end there is a line on the surface. That is a kind of, you can see the peripheral. Okay, the peripheral of the surface, the line around the surface. If you want to calculate the energy taking a particle that is moving from one point and coming back to the same point in a closed path, then if you know the curl factor, because biggest investigation is going on the curl factor, df2 by dx minus df. If you have df2 by dx minus df1 by dy, if you know the curl factor, if you do dot product and integrate along the area that is forming through the area vector, curl vector dot d of area vector, you will get the energy along the circulation. Why someone is going like this? Why someone is not calculating simple f1 dx plus f2 dy? Energy along any curve is simple force vector dot d of position vector. That's it. That is f1 dx plus f2 dy. Rather than first you calculate the curl vector and then dot d of the surface area vector, and that integration will give you the kind of the energy calculated in the circulation path. Whatever I will talk, I believe it is too much time now. Whatever I will talk, that is not available in any of the book. Why we need Stokes theorem? Stokes theorem says if you have a curl vector and if you integrate the curl vector along area, curl vector dot product, curl is a vector, dot product d of area vector, all are algebraic. If you get integration, then integration along the surface, full surface, then whatever the line that is end of the surface, whatever the closed line it is connecting, that energy you can calculate, or line integral you can calculate. Line integral is energy. Okay, why we will go through? This is the one approach to calculate the line integral along a closed curve through the curl vector. People know that that is same as if you have the curl vector dA. Curl vector dx dy, it also gives the energy only, but it is directionless. That is the problem. If I say I know curl df2 by dx minus df1 by dy, right? Df2 by dx minus df1 by dy. You get something, right? Dx dy. Integrate along the closed region, you get the line integral along the peripheral or energy calculation. Why you want a Stokes theorem? Stokes theorem is required because we are not doing df2 by dx minus df1 by dy. Dx dy is d area, but here there is no direction. Now, Mr. Stokes, Sir Stokes, he saw that curl vector, what we are calculating, it is a vector. And if I am integrating along dx dy, that is not a vector. It should be vector. It is something like, we are doing some kind of incompleteness. This is what Stokes is seeing. So df2 by dx minus df1 by d, if I have a curl vector dot product d of area vector, now it is complete. This is what he is saying. Now it is complete. If curl is a vector and I am integrating blindly in any surface, whatever the surface coming in, if I have a curl vector, the way if I have a curl vector, I am integrating along any surface, this is not complete. Curl vector dot d of area vector. Now integrate in the closed region, that will give you the actual energy of the line integral of the peripheral of it. So we will proceed on it, or someone can think like, consider there is a circle of radius A. There is a circle of radius A. There is a force field that is minus 2yi plus 2xj, famous example. Minus 2yi plus 2xj. There is a force field like this. Minus 2yi plus 2xj. There is a force field like this. If there is a force field like this and there is a surface in yz plane, then how much is the line integral of the circle? Circle is kept in yz plane. Circle is kept in xz plane. Circle is kept in xy plane. Now calculate the energy. If we don't go through Stokes theorem, because here area vector is this. 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 Everywhere area vector is changing. Area vector has importance. This is what he is saying. But this is a flat, so area vector all around the surface is in one direction. If it is not flat, this is a cloth that is sewed along this, and then I pull the cloth, then everywhere area vector is different. No problem. Force vector and curl vector dot d of area vector. Now area vector is algebra, curl vector is algebra. So every point it will be different. So all right. And then if you calculate that integration along the full surface, you will get the energy along the sewed region of the cloth. That is the line integral along the curve. That is the energy calculation. So someone calculate what example I gave. Force vector is minus 2yi plus 2xj, and then circle is kept in yz plane, xy plane and xz plane. Now calculate the energy calculation directly through whatever it is and through Mr. Stokes theorem, Sir Stokes theorem. So that way we'll proceed on. Please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.